Hey guys, it's Coach Hammock. This is 3-3 rate of change and slope. Let's do it. Here we go. We've graphed ordered pairs. We're going to do change of slope. All right. Rate of change is the change in y over the change in x. A lot of times you'll see it delta y over delta x. Delta is just a triangle. It's a Greek letter in the alphabet, in the Greek alphabet. So delta is always referred to as change in y, change in x. You'll sometimes see it in chemistry as change in temperature. All right. So let's see this to find the rate of change. Basically, guys, what we want to do is we're going to draw these alligator teeth, what I call alligator teeth on the sides. Okay. And we're going to find the change in these. So right here, 152 or 76 from 152 would be 6, 5, 4. That's 76 right there. Okay, and 228 minus 152 is 76. We're going to go over here. We're going to figure out if we have the same rate of change. All right. Well, it goes by twos over here. So our change in y over change in x would equal 76 over 2, which would equal 38. All right. Our slope is basically going to be 38 over 1 right here. All right. Change in y over change in x. There are a whole lot of slides in this show. I'm going to skip a lot just to keep it down. Right here, you can find the rates of change on a graph between points. So right here, you see how it goes up 2 from this point to this point? Well, remember, that's our change in y. That's our change in y right here. It goes, it's not 2, it's 1.9. 8.9 minus 7 would equal 1.9. Sorry, I don't know what's up with that. And there's 2, the change in x, 2004 to 2002 would be 2. All right. So we are working this out. So if we reduce that down, you can leave it as 1.9 over 2. That's fine. Or you could go 0.95 over 1. All right. And that's fine as well. It doesn't have to be whole numbers. It can be decimals. Whole numbers will make it easier for us though. All right. Like I said, skipping a little bit. Okay, so we're going to determine if this is linear. Linear functions have the same slope throughout. They have the same rate of change. So what's the rate of change over on this side? It goes up by 1 every time. To go from 6 to 12, that's plus 6. From 12 to 18, plus 6. And from 18 to 24, that is plus 6. So my rate of change is 6 over 1 throughout. Everything is the same. So is this linear? Yes, it is. It is a linear function because the rate of change stays constant. All right, let's try this one. To go from 5 to 1 is minus 4. To go from 1 to negative 4 is minus 5. And golly, I don't know why it's doing that, guys. Sorry about that. It's making it hard to see. All right. And then to go from negative 4 to negative 10 is negative 6. All right. Let's go over here. Now, these are different, but I'm not 100% sure that it's not linear until I come over and I see this side and I make sure that, like if it was, to make sure the fractions are not the same. Okay, and I'll show you what I mean by that. Negative 10 to negative 2 is plus 8. Negative 2 to 6 is plus 8. And 6 to 14 would be plus 8. So what we're going to do is we're going to look at these 2 points. I've got negative 4 over 8. Okay, just leave it like that. The middle 2 points, this one and this one, the rate of change is negative 5 over 8. And then the last one is negative 6 over 8. Now, my question to you is, are these the same fractions? And no, they're not. Okay, so this is not linear. All right, it is not a linear function. All right, again, we can do that right here. looks like everything on this side is plus 2. From 2 to 4 is plus 2, 4 to 6 is plus 2, 6 to 8 is plus 2. And everything on this side looks like it's plus 5. So it looks like from every step, it's going to be 2 over 5. So is it linear? Yes, it is. The rate of change is constant. Okay, I'm going to skip this. Go right here. Now, with 2 points on the graph, we're just going to go y2 minus y1 over x2 minus x1. Many of you have already seen this from last year. Just know that it doesn't matter which one is the second point, first point, second point. It doesn't matter, okay? All that matters is you keep it straight. All right, so let's go here. We're going to find the slope of -3, 2 and 5, 5. We're going to say that this one is our first point. We're going to say this one is our second point. So M slope equals y2 minus y1 over x2 minus x1. Wow, I just do not understand what's going on. So anyway, all right, so we've got 5 minus 2. All right, over 5 minus -3. Okay, remember it's always minus. So let's do this real quick. It looks like it's going to be 3 on the top and an 8 on the bottom. Okay, 3 on the top and 8 on the bottom. So my slope equals 3/8 right there. All right. Okay. Find the slope that passes through this. Again, I'm going to say that this one's 2 and this is 1 right now. Okay. So -4 minus -8 over goodness gracious, -3 minus -2. And that looks like plus plus. It's going to be 4 over -1, which would equal a slope of -4. All right. Well, we've got a few more examples right here that I'm not going to go through. If you want to pause the video and look at these and work them out, that would be great practice for tomorrow. Okay. As far as undefined, we'll talk about that tomorrow in class. Hopefully y'all are keeping up with everything. This is pretty good right here. If you know positive slope, negative slope, slope of 0, undefined. This is good stuff. All right. Very good. All right. So that's all I got for you today. We'll do some of this on Friday. There will not be a video over the weekend, of course. So come to class ready to review this stuff, and we'll keep it working. All right. Y'all doing a great job in here. I know it's confusing sometimes, and it gets to be a lot of work, but just keep it up, guys. Y'all are rocking it. We'll talk to you later.